Alrighty, so if you watched part 1, we finished with the height of the building being h equals 125 tan 32. So the height of this building here, right, the height of this building right here is 125 tan 32. Now again, you don't know what that is off the top of your head, so I'm going to show you on a TI-30X, which is the version of a calculator that we have in class, how to get a decimal as to how high this actually is. So what you're going to do on your calculator, you're first just going to type in 125. Oh, that's not the pen that I want to use. You're just going to type in 125 as usual. Okay? So you type in 125. Then you're going to look on your calculator. You'll notice right here you see a button that says tan. That does not mean you can press it and get a tan, right? That's so you need to go to a tanning salon for that. That button represents the tangent ratio. So what you do here is you hit that button, or I'll put it in a box because it's a button. So you hit the tan button, so 125 tan, and then you hit 32. If you notice on the actual calculator screen, it has this multiplication symbol here, which you do not have to use. Okay, it's implied when you type this in your calculator. It's implied that there's multiplication there, but you do not have to type that in. Okay, so you get 125 tan 32, which gives you 125 tan 32. Let me type this in. 78.10866.9. Now, again, looking back at our picture, we solved for h. We got 125 tan 32, which means the height of this person in the window, the height of that person is 78.10 blah 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 blah, about 78 feet. Okay, so your answer would be about 78 feet. If I ask for an exact answer, you would leave it in this form. Exact answer, you leave it in this form. If I said to give me an answer to the nearest tenth, or the nearest hundredth, or the nearest thousandth, or whatever, then you would type it into your calculator and you would round. So here you would round, or oh, I know how to spell round. You would round / estimate. Okay, because this is not necessarily exact. Okay, so you're rounding / estimating. Okay, so that's how you type that in your calculator. Now, another cool thing you can do on your calculator is you can kind of go in reverse. You can, because, I mean, let's look at this problem again. The odds that you're walking down the street and you have a protractor is limited. Now, it's not impossible, because I think everyone should walk around with a protractor in their pocket, but finding this angle of 32 is going to be difficult in a real-world situation, right? You could do it if you lay on the ground, put the protractor on the ground, measure up, but people might look at you a little funny. So there's a way to do these problems where you can then solve for the angle. Okay, so you can solve for the angle. So let's look at this triangle here. We know that it's a right triangle. We know that one of the legs is 41, and we know the other leg is 47. Okay, what we want to do is we want to solve for this angle x. We want to solve for this angle x. Now, if you notice, again, we're using the leg lengths, and the ratio, we're going to learn about 2 more ratios later, sine and cosine, that involve the hypotenuse. But in this case, the ratio of the leg lengths is the tangent ratio. Right? Tangent ratio. So we're looking at the leg lengths. Tangent of which angle do we care about? Well, we care about this angle x, right? So we're going to write tangent of x equals, again, the opposite side length of x is the side on the other, or the leg on the other side of the triangle, right? So the opposite, again, don't forget TOA, that's the phrase you need, or the abbreviation you need to remember, okay? The opposite leg is 47. The leg that's touching x, the adjacent leg, is 41. So again, opposite over adjacent. Tangent, opposite, adjacent, TOA. Okay? But this doesn't help us solve for x. You could type in 47 over 41 on your calculator, which gives you tangent of x equals, if you want to know a decimal there, 1.1463416. Now the reason I have so many decimal places is because I want to be as precise as possible. I don't want to round, because then it will, if I round here, it will affect my angles, my angle measure. So I want to be as close as possible, and then if in the answer I can round if they tell me to. Okay? But here's how you solve for this. So again, I'm going to look at a calculator question. Okay? So here's how we solve for this. You have tangent of x, tangent x equals 1.4, man, not 4, 1.1463416. So if I'm looking now at my calculator, right, if I'm looking at my calculator here, in order to solve this problem, this is what you're going to do. If you're writing this on paper, you're going to write this. X equals tan inverse. This is not tan to the negative 1. This is pronounced tan inverse, or inverse tan. Okay, it could be pronounced inverse tan as well, but tan inverse of this number, 1.1463416. Okay, again, I want to keep, it's a pain, don't be lazy though. It's a pain to write the decimals, but it's only 2 seconds out of your life. Okay, it's not a big deal. Now, how do we do this on the calculator? This solves for my angle measure, right? It solves for my angle measure. So this is the cool thing about this, is we can type in, there's a button. Again, if you look at this tan button, right above that, you see a tan inverse thing. It's not the actual button, it's right above the button. So it's right here. Oh, no, it's not. That was a fail. My fault. So it's right here. Okay? So you see tan inverse real small right there. So how you get that is you type in second, which is this button right here. Second. Second. And then you hit the tan button, and what that does is it takes you to this upper command. It's like hitting shift on your keyboard. It takes you to the symbol right above the key. Okay, so second tan, which then, again, this gives you tan inverse on your screen. You should see this on your screen now. Okay, then you're just going to type in your number. Okay, 1.1463416. When you type that in, you hit enter, and you end up with approximately, I'm going to round to the nearest hundredth here, 48.90, or 48.9. Okay, which means, let's go back to my picture. We're solving for my angle measure. My angle measure here is 48.9 degrees. It's approximately 48.9 degrees. Okay, it's approximately 48.9 degrees. Now, real quick thought, and I promise I'll let you go on with your day. Okay, it would not make sense for this angle to be less than 45. Let me tell you why. The side length opposite, so I already have the arrow on here, this side length opposite the angle x is the bigger leg, right? It's the bigger leg, which means x must be a larger angle than y. X must be larger than y because y is opposite the smaller side, x is opposite the bigger side, right? So if x must be larger than 45, if they were equal, I mean, it must be larger than y. If they were equal, they would both be 45, right? So you'd have 45, 45, 90. So if x must be larger, it must be more than 45. So if you end up with an answer like 36, it's not reasonable. It doesn't make sense. If you ended up with an answer like y equals 36, it would at least make sense because it's smaller than 45. Okay, that's not technically the right answer because it must add up to 180 here, and we know what x is, but that's not the point. Okay? The point is, it must be a reasonable answer. Your big angle must be more than 45. Your smaller angle must be less than 45, or else it doesn't work. Okay? So again, we're dealing with a calculator, so I can now put decimals on your tests, as much as that saddens you, but I can. We're dealing with a calculator. We're solving for angle measures. We're solving for side lengths. And that's it. See you tomorrow in class. Bye.